Hey guys, easiest lesson ever today. We're going to do sine and cosine functions as complements, and we're going to figure out what that means. So that is your topic statement, and as your I can statement, we're simply going to learn how to recognize that sine and cosine functions are complements of each other. So the first thing we'll do on the next page is remember what this word complements means. Alright, so vocabulary, the biggest thing to get going is just remembering what complementary angles mean. It can be more than two angles, but in this case we'll just say it's two angles who together their sum is 90 degrees. Should remember that. So this sentence right here, a postulate, is just kind of like the word theorem, fancy way to say something that's true. That sentence you should definitely write down. Sine and cosine are co-function identities. We're going to draw a picture which will hopefully make sense of those two statements. So you might want to draw the picture first, and then if you'd still like to copy those two statements, you can. So let's all draw a typical right triangle. Let's name it all the same. Let's all call it triangle CAT, cat. Let's put these side lengths on it. You probably know by now 3, 4, 5 is a very common right triangle. The best way to kind of understand this concept is to pretend it's just angle A and angle T talking to each other. Sounds weird, but just stay with me. So let's say I'm angle A, and I say, hey there, I'm angle A. Let me tell you about my sine. My sine will be my opposite over hypotenuse side. And when I'm sitting here at angle A, that would be opposite is 3, hypotenuse is 5. And then if I say that to you and you're angle T, you might say back to me, well, I'm angle T. Let me tell you about my cosine. Cosine of angle T would be your adjacent over hypotenuse side. When I'm sitting at T, the side adjacent to T would be 3, hypotenuse is 5. Well, wait a minute. If you look at that, and you've kind of introduced each other, angle A to angle T, you realize that that's the exact same thing. So what we've got going on here is that the sine of angle A equals the cosine of angle T. And if we had actual measures of the angles, for instance, let's say angle A was 40 degrees and angle T was 50 degrees, then that would mean that the sine of 40 degrees should be the same as the cosine of 50 degrees. Check that out in your calculator if you'd like to. They both turn out to be, when you punch them in separately, that decimal value. And that is really all there is to it. So let's give example 1 a quick look. The sine of one angle in one acute angle in a right triangle should be equal to the cosine of the other acute angle in a right triangle. So in example 1, if they tell us to find the sine of 28 degrees if the cosine of 62 degrees is approximately 0.469. Well, here's what we have to check out first. 28 plus 62. We want to double check if those are complements, complementary angles. 28 plus 62 is 90 degrees, so they're definitely complements. That means the sines and cosines of each other would be the same. So you can check it out on your calculator, but the sine of 28 degrees will be 0.469, simply because the cosine of that complementary angle is 0.469, and that's all there is to answering it. Let's look at example 2. Find a value for the angle theta so that the sine of theta would be equal to the cosine of 15 degrees. So let's start right here. Cosine of 15 degrees, we want it to be equal to the sine of some other angle. So to find that other angle, you simply find the complementary angle to 15 degrees. That's 75 degrees. So theta should be 75 degrees. Please, though, just since it's all still new to you, check it out on the calculator. Type in the sine of, not the sine of theta. Type in the sine of 75 degrees. Type in the cosine of 15 degrees and see if they're the same thing. I believe they both turn out to be this. So that's how you double check yourself. But it's as simple as they give you one angle, you find the complement to that angle. Fake tans, no matter what you think, not good for you. All right, example 3. If they want us to complete this table by using the sine and cosine identities, that's as easy as double checking that these are complementary angles. Yes, they are, because they add up to 90 degrees. And then that means the sine of one would be the cosine of the other. Super easy to fill out. Don't even need your calculator unless you just want to check it. Sine of 80 degrees should be 0.985. Cosine of 80 degrees should be 0.174. Example 4, same concept, but we need to have several more missing blanks now. As you can tell, sine and cosine of those two angles have already been flip-flopped, so that means the 0.883 does the exact same thing. And we just need to fill in one more missing angle. How would we do that? Same way we've been talking about the entire time, complementary angles. So if you can take 90 degrees and subtract 28, you'll know what that other angle is. It should be 62 degrees. So you can either find the angle if you know one, or you can find the sine or cosine of both just by knowing one simple thing. And that is it. So just to make sure you know what's going on, review through the quick 4 examples because they are that quick. We will have a quiz next time which will cover identifying all of your 6 trig functions and also these complement functions, which basically means if you know one sine, you know the cosine of the other. So please start making it a goal to finish all of your homework on time and getting things turned in every day. Most assignments can be done in one day's class time. Thanks, guys. Have a great day.